You want to sit in the class?
All right, so let's review this real quick. Yesterday, if these three were going to be the sides of a triangle, then the sum of any two sides has to be greater than the third. So that means that 5 plus 7 has to be greater than 8. That means that 7 plus 8 has to be greater than 5. And that means that 8 plus 5 has to be greater than 7. In this case, all of those work because 12 is greater than 8, 15 is greater than 5, 13 is greater than 7. So these form a triangle. Number 2, does this form a triangle? No. Because if I take 4.2 and I add it to 4.2, that is not greater than 8.4. Equal to, but not greater. Number 3, is it a triangle? No, because 3 plus 6 is not greater than 10. Now the range of sides, this is what this one was right here. This is the more complicated part here. If I have two sides, 4 and 13, and I'm looking for the range of sides that this third side could be, the same rule applies. 4 plus 13 has to be greater than x. 13 plus x has to be greater than 4. And x plus 4 has to be greater than 13. So if I solve all of these, I have 17 is greater than x. I have x is greater than negative 9 when I subtract 13. When I subtract the 4, x is greater than 9. Well, clearly, this one can't work. Because even though x is greater than 9, x could be negative 8. And clearly, I can't have the side of a triangle that's a negative. So this one does not work. So then we're saying x is greater than 9. X is greater than 9. And x is less than 17. Okay? Or we can write it as 9 is, x is greater than 9, and x is less than 17. Now, here's a shortcut, Megan. If I say, Megan, give me two numbers. Any two numbers? 28 and 32. And I want you to find the range of values for x. The easiest way to do this is we're talking about all values of x between what these two added together equals, which is 60, and what this minus this is 4. Okay? Okay, the reason why. Because chances are a mean teacher could say, this is a side, this is a side, and this is a side. It's here. I'm slowly flipping this out. Okay? So therefore, you would have to set it up in the I'm going kind of a mood on this. But the next section and the last section in this is what we call the hinge theorem. Now, we're going to, this is the rules that come out of the textbook, but we're going to look at this for a second. Let's take two triangles. All right, so we're going to call this ABC. Call this C, D, and we're going to let this angle right here be 45. And we're going to let this angle be 30. Okay? You with me, everybody? This is not hard, but you do pay attention. Okay? Which side is bigger? Is BC bigger or is EF bigger? Okay. So if I ask you for the relationship between BC and EF, that relationship is that BC is greater than EF. Okay? That's what this theorem says right here. So, if I look at this and I say compare the measures between AD and BD. Alright, compare the measures between AD and BD. What's the relationship between AD and BD? AD is greater than BD. Okay? What's the relationship between angle ABD and BDC? ABD is greater than BDC. Okay? Yes? Alright, so find all possible values for A. I'm going to let you do this. Which one is bigger? 9A plus 15 or 18? So across from 9A plus 15 is 16. Across from 141 is 18. Which one is bigger? Okay, 18 is bigger. So 9A plus 15 is less than 18. Yeah, we solve for A. So we're going to subtract 15. And so 9A is less than 3. 9A plus 15. Wait, why did I take 18? Thank you. Oh, sorry. I was wondering why that was going to work. That was going to work out weird. Okay, sorry. Shh. 141. Thank you. All right, so 9A is less than 126. So A is going to be less than 14. Okay? So A is less than 14. Do we agree with that? Yes. So every value of A that's less than 14 we're good with, right? So I'm going to go ahead and put negative 1,000. Because negative 1,000 is less than 14, right? So we're talking about every single value of A that is less than 14, right?
Sure. We're not going to do less than negative.
Well, think about it for a second. Hold on. Is negative 1,000 less than 14?
Yes.
Can I put negative 1,000 in here for A? Why?
It's going to be negative.
Because it's going to make my angle negative, right? But it's going to make my angle negative, right? If I plug in negative 1,000 in here, negative 9,000 plus 15 is negative whatever. Okay? So I have to make sure that this angle right here, is going to be larger than 0. Because I got to make sure that this is going to be positive. So then I have 9A is greater than negative 15,
Mine is negative.
huh?
So I'm just confused. But I can't.
See, if the first way I solved this was A is less than 14, but that doesn't mean that every single value of A can be true. If I put negative 1,000 in here, that's going to give me a negative angle. So I have to make sure that I'm talking about all of the values of A that are less than 14 and all of the values of A that make this angle positive. So then I have negative 15 over 9, which reduces to negative 5 over 3. So we're also talking about all of the values of A that are greater than negative 5 over 3. So then my solution, huh? Negative 5 over 3? Right here? Because when I made sure that this angle right here was going to always be positive, I had to make sure that this angle was always going to be bigger than 0. So I said this angle has to be bigger than 0. So then I solve for A to make sure that I know all of the values of A that make sure that this is going to be bigger than 0. So I have to account for all the values of A that are greater than negative 5 over 3. So my solution is all the values of A that are less than 14 and all the values of A that are negative 5 over 3. It's a range of values. Oh. All right, do this last one right here and then we'll be finished. No, no, this one. This is 7A plus 5. This is 47. This is 9. This is 11. We recognize that this angle right here is larger than this angle right here because the side across is 11. The side across is 9. So therefore we have 7n is greater than 42. And so n is greater than 6. You okay with that? Mm-hmm. Fantastic. So let's let n equal 1 million. Doesn't matter. Okay? My question is, all the values of n that are greater than 6. Right? So there's an infinite number of values for n, so I can let n be 1 million. Right? Can I put 1 million in here for n? Can this angle be 7,000,005? No, it can't. What's the largest value an angle can be? 360. So therefore, I have to make sure that this angle right here is less than 360. What is it? Yeah, give me the decimal.
50.7.
50.7. So then we're saying n has to be less than 50.7, and n has to be greater than 6.